Okay, this is your data and interest test corrections reteach. So you're going to get a sheet of paper and do your test corrections for the ones that you got wrong. All right, number one, Katra deposited $625 into a savings account that pays 6% simple interest. How much interest will she earn in 5 years if she makes no more deposits? Round your answer to the nearest cent. So I notice first it says simple interest. So I go to my reference chart, and this is the formula I write down. Okay, now this formula will give me interest, and that's exactly what my problem wants, so that's all I have to do is use that formula, and I'm done. Principal is the money I start with, that's $625. R is rate, that's your percent. Don't forget to put the percent sign in your calculator. And T is time in years, and that's 5 years. That my calculator, and I get 187.5. Now it says nearest cent. That does not mean nearest dollar. You do not want the store, when you go to buy something, to round things up to the nearest dollar. Okay, this is why we have quarters and dimes and nickels and pennies. So 187.5, and you can put the 0 there if you want, but you don't have to. Okay, number 2, Carlos is looking at different savings account options to save for college. First Bank offers 1% interest compounded annually. Community Bank offers 2% simple interest. Carlos is depositing $1,000 into the account for 4 years with no additional withdrawals or deposit. Which bank is a better choice? Okay, so I want the bank that's going to give me more money because I'm saving. So the first thing I'm going to do is kind of make a little list because I have 2 different things going on. So I'm going to have, let's see, First Bank. Okay, First Bank gives me 1% compound interest. Okay. All right, so it's $1,000 for the P each time, so P is 1,000. Time is 4 years, and then my rate, it's different for each of them. So this says compound, so I'm going to use this formula, capital P, 1 plus my rate to T. So that means it's the total amount in my account when I'm done. All right, so let's see. I have 1,000 times 1 plus 1% for 4 years, which gives me 1,040.60. So $1,040.60. That's the total amount I have in my account. All right, let's go and figure out this other one, Community Bank, 2% simple interest. So Community Bank charges 2% simple. Okay, so simple interest is this formula, and you notice that gives you just the interest. So to get the total amount, you're going to have to add. This gives you just the extra money that you earned. Okay, so my interest is, let's see, 1,000 times 2%, and again for 4 years. And that gives me $80. So that's my extra amount. So the total amount in the account with Community Bank is the $1,000 I started with plus the $80 extra dollars I earned. So that gives me $1,080, which is more than $1,040. So I'm going with Community Bank. So let me go see what my answer choices say. So it says First Bank's a better choice. Nope. First Bank's a better choice. Nope. Community Bank is a better choice because his balance will be $1,080 after 4 years, or $8,000 after 4 years. Well, we got $1,080, so C is your correct answer. Okay, number 3. Tanya's parents put $1,500 into a college savings account that pays 5% simple interest. If the current balance is $4,325, about how many years has been in the account? Okay, so first thing I notice is this says simple interest. Okay, so I notice the simple interest formula gives me just my interest. So I have to figure that out because I have 4,325 and I started with 1,500. So to find out how much interest that would be, I have to subtract. That's how much I have now. That's what I started with. So I need to subtract to figure out how much extra money I earned. Okay, so looks like 2,825. Okay, that is I. Okay, and I know that P is 1,500. This is my R, and I'm trying to figure out T. So you have a couple options. You could do 1,500 times 5% times 10 years and see if you get 2,825. I'm going to solve it algebraically because that's what I do. 2825 equals 1,500 times 5% times, let me scooch over here, there we go, times T. So I have to figure out what T is, so I can do that. And I get 75 times T equals 2825. So it's just a one-step equation. To undo this multiplication, I divide by 75. Now this problem doesn't come out exact. I think I changed it from an old problem and didn't do a good job at changing it. So let's see. 2825 divided by 75 gives me 37.6, etc. So about 38 years, which, I mean, for college, doesn't seem like a reasonable answer, but that's what we get. And so the closest to 38 years will be 40 years because it's only 2 years away instead of 3 years away. Okay, what is the ending balance of an account that is opened with $1,200 invested for 10 years with 5% interest compounded annually? And we want ending balance, which is good news because that's exactly what compound interest formula gives us, the ending balance, the amount in our account, the total amount. All right, so principal 1 plus the rate to the power of t. So that's 1,200. 1 plus 5% to the 10th power, which gives us 1,954.673. So that rounds to D, 1,954.67. Okay. Which of the following shows how to calculate ending balance of account with a beginning balance of $600 that earns 2.5% compound interest over 8 years? Again, compound interest, and they want ending balance, which means we just need to use the formula. Okay, so P is 600, R is 2.5%, and T is 8. Okay, so I definitely know it's not A. And so now I have these choices. B, C, and D basically are asking you to convert that. So if you're not sure about that, you can put it in your calculator, 2.5%, enter. It will tell you the answer. Or you could figure out what that is in your calculator and then put each of these in and find the one that gives you the same answer. Okay, 2.5% is 0.025. So our correct answer is D. Okay, data part. The last 6 days of August 2011 set all-time records for high temperatures in Austin, Texas. Which of the following best identifies the mean absolute deviation, or MAD, for these temperatures? Okay, so mean absolute deviation, remember that's where you find the mean twice. So you first need to find the mean of the temperatures. So these are not numbers I'm going to use in my mean. Those are just descriptors like Monday, Tuesday, Wednesday, or whatever. Okay, so I'm going to find the mean of these. So I'm going to add them all together. Then I'm going to divide by 1, 2, 3, 4, 5, 6. Okay, Okay, and when I do that, I get 107. Okay, so let me add them all together first for you. Okay, so when you add them, you get 642. Divide by 6, and that does give you 107. So be careful. Look, right there is your answer, 107. That's not going to be a mean absolute deviation. Mean absolute deviation answers are usually between 1 and maybe 15. You won't have anything like 107. That's way too big. Because remember, the mean absolute deviation tells you how far away you are from the mean. If you're finding the mean, which is an average measure of the numbers, how could you be 107 units away from the mean? Okay, so 107 is your first mean. What you do with that now is subtract it from each of your data points, and you use the absolute value. You find the distance each of these temperatures are from the mean. So I'm going to subtract 107 from each of these, okay, etc. I'm going to get a new list of numbers. So 103, the difference between 103 and 107 is a difference of 4 degrees. The difference between 110 and 107 is 3 degrees. 112 and 107, that's 5 degrees. 109 and 107 is 2 degrees. 105 and 107 is also 2 degrees. And again, the difference between 103 and 107 is 4 degrees. Okay, so that's how far each of those points are away from the mean. So now I need to find the average of that, the average distance away from the mean. So I find the mean again. So I'm adding all of these up. 4 plus 3 plus 5 plus 2. I'll write it down. 4 plus 3 plus 5 plus 2 plus 2 plus 4. And then I'm dividing that by 6. Okay, and when I do that, I get 20 divided by 6, which gives me 3.3, and that repeats. So my correct answer is D, 3.3, which actually tells you statistically that your numbers are pretty close to your mean. There's not a lot of variability. Okay, so that brings us to number 7. What information does the mean absolute deviation provide about a data set? So each of these say the mean absolute deviation describes the average distance each value in the data set is from. The median, the mean, the zero, the range, okay? So we didn't talk about anything but the mean, A, and B, it is called mean absolute deviation. And like I said in the previous problem, it is a measure. It tells you how far everything is from, all your data is from the mean. Whoops. So answer B is your choice. Okay, so this one, the graph's here, it was cut off, and then the answer choices are on the next page. So let's just look at this graph and see what we notice before we go look at our answer choices. So this says the scatter plot below shows the gas mileage and weight, which must mean, since that's gas mileage, your weight is here on the x-axis. Okay, and the x-axis always starts from 0 and increases. So which is the best interpretation of the scatter plot? So let's see what's going on. So this looks like as my weight of the vehicle increases, the gas mileage decreases. Because I say I have this negative correlation going on. Okay, which is why smaller cars get better gas mileage than big old trucks. All right, so let's look at the answer choices and see if we can match that to an answer choice. All right. As the weight of the vehicle increases, the gas mileage stays the same. No. That would be like a... Sorry, that was my alarm. Okay, as the weight of the vehicle increases, the gas mileage stays the same. No, that would be like a horizontal line. It's definitely not staying the same. Vehicles that weigh the least seem to have higher gas mileage. Vehicles that weigh the most seem to have higher gas mileage. As the weight of the vehicle decreases, the gas mileage stays the same. Nope, it's not staying the same. So we gotta look at these two. So we said on the previous slide, as the weight increases, the gas mileage decreases. So they're going in opposite directions. Okay, so this is the same direction, way more and have higher gas mileage. This is opposite directions, way the least, have higher. So if as the weight increases, the mileage is decrease, we could also say as weight decreases, mileage increases. We just need these to go in opposite directions. So that would be letter B. Okay, next one. The coach of a group of debate teams answered a survey about hours of debate team practice and number of team wins. And then we have our graph, and it already has a trend line drawn. Remember, a trend line has to go like kind of in the middle of your data. You should have equal number of points above and below the line. So using the trend line, if a team practices 4 hours per week, 4 hours per week next season, which is the best estimate of the number of debates they can win. So hours is here on the x-axis. So we're going to 4. We're going up till we hit our line, not that dot. You have to hit the trend line. That's why it's there. And then you move over here and you see that it's 16. So letter C, 16. Okay, and last question. Based on this scatter plot, which type of association exists? There is no association, a linear association, nonlinear association. Average association, that's not anything we talked about, so if you haven't heard of it, probably not the right answer. Okay, so let's see. Is it linear? Doesn't appear to be linear. I don't see a line, but I do see this kind of curve, so it's not linear. Okay, it's non-linear because there is a pattern here. There's a curve. No association. Remember, that looks like this. Just all over the place, random. That's no association. This has a pattern. It has some kind of association. It's just not linear. So your answer is C.